Unit 4, Measuring Prisms and Cylinders, Grade 8 Math. Before we go on to this chapter, there's a couple things you need to remember from last year. The first thing is remember the area formula for a triangle. The area of a triangle is going to be equal to the base of the triangle times the height. So the base, the bottom here of the triangle in this case, is going to be 6. Don't forget, it's not only going to be the base times the height, it's got to be half of it, because a triangle is like half of a parallelogram. So it's going to be half the base times the height. So in this first one here, let's take half of 6 and then times it by the height of 3. So half of 6 is 3. Times it by 3 and you will have 9. If we take this one, half of the base, here's the base, half of the base is 1. 1 times 3 is 3. For this one here, half of the base is right here. Half of that is 1. Times it by the height, and the height goes from here to here, is 2.4. So 1 times 2.4 will give you 2.4. So that's the formula for the area of a triangle, or all this space inside a triangle. So remember that one. For a circle, to find the area inside it, you've got to multiply pi, which is always the same number, 3.14, times the radius squared. So the radius in this case is 5 squared. Now if you didn't know the radius, but you were given the diameter, the whole thing across, and it was 10, then you just take half of it to get your radius. So it'll be 10 divided by 2 is 5. So now all we have to do is 5 times 5 is 25. And then we got to times that by 3.14. And we will have something in centimeters squared. It'll be just over 75 centimeters squared if you work it out using a calculator. So that area will give you all this here shaded in here if we were to shade it all in. So you need to remember that before you start the unit. And the last, of course, is a rectangle or a square. It works the same. Parallelogram we're not going to worry about right now, because we're not doing it in this one yet. But a rectangle is just one side times the other. In other words, the base times the height, but the base is the side here. And the height, of course, is the other side in a rectangle. So it's one side times the other side, length times width. If it was a square and you wanted to find it, it would simply be one side multiplied by the other, okay, or this squared. So now that you know those three, it should be pretty easy to do any kind of problems using these complicated shapes. First thing you need to know in section 4.1 is exploring nets, is that a prism and a pyramid can be unfolded into shapes. So remember, a prism, okay, such as this one right here, will have a top and a bottom to it. Okay, it won't come to a point. Not like this here pyramid here. This here prism does as well. So this one right here is another example of a prism. Okay. A rectangular prism right here can be unfolded to make these shapes. A triangular prism can be unfolded to make these shapes. Okay. So it's basically, if you cut them all up, you would end up with something unfolded that would be these particular shapes. Now how can you tell which shapes are which and what it's going to unfold into? Just start with one of the sides. So I might start with this side right here. Okay? And I'm going to label him 1. So I'm going to say this is this one right here. And then I go to the bottom of them. And I say this one is the bottom. So I'm going to put B for bottom. I can say then the opposite side is another, in this case a pentagon. So that'll be side 2. And then you can see to one side, to the right, on this side is another rectangle. And then you've got the other side would be another rectangle. And then they're all rectangles forming this here prism. So we're going to concentrate on prisms right now. Again, we've got 1, 2. You can't see it, but there's another side to this. So that would be 2 there and 1 there. And then, of course, you've got your top and your bottom. So if this one is your bottom, this one will fold over to give you your top, and these two are the sides. The one thing you got to notice when you're looking at them, let's take this square. So this square is this one right here. When it's folded up, so let's go up from the bottom, and that is 2 centimeters right there. Of course, the bottom here is 3 centimeters, so that would make this 3 as well, and this 2 as well, because it is a, well, almost looks like a square. In this case, it's a little bit of a rectangle. The long side of this one here on the bottom is this long piece right here. So if this is 6, this is 6, this is 6, right? We know this is going to be 3 if we fold it up top. So we can work out most of these. This one up here is 3. So if we fold that over, that's going to be 3. So you can follow it and pretty much figure out what each side is going to be. So this is going to be 3, so the opposite side here must be 3. This was 2 over here, so the opposite must be 2 there. This was 6, so this must be 6, so this must be 6, and so on. The same applies with this guy here. You know that this side is also the same as the side of this rectangle. So, and there you go, an example of the sides that are the same. I should say edges. In this triangular prism, you know you're going to have 2 triangles. So 1, 2 triangles. And you're going to have 1, 2, 3 rectangles. In a cylinder is a little different. You know you've got a circle on the top, and you know you've got another one on the bottom, unless it's hollow and there's nothing in there. But if you were to slice this open like a soup can label, it would fold out to become a rectangle. And of course, you do know that the height of your can is 10, so this is also the rectangle's height right there. You know the diameter of the entire can. You don't know the circumference or the distance around the circle, but one thing to note is that the distance around the circle is also, if I were to stretch that out, equal to one of the sides of your rectangle if you were to unfold. That'll become important a little later on when you're doing the formula for surface area. In section 4.2, you're going to be creating nets, okay, or creating objects from the nets. So in this case, I've told you it's a cube already. You could start and say this is your bottom or your base. When you fold this up, you fold that one up, fold this one up, and you fold that one up. You'll have the 4 sides. So this might be the front and the back. This might be side, side, and this would be your top. So let's look at some of these and see if we can match the 3D shapes with their nets. The easiest way to identify them is look at what the shape of the base is in most of them. Okay? And that'll usually tell you, okay, there's a base. There usually will be 2 of them. See, there's 2 of them there. And you can usually tell where the bases are. So let's take this one right here and match them up with this one down here. We've got 2 bases that are hexagons. And if we match that hexagon up with something that has a hexagon base down here, or 6 sides, you'll notice that this one here is the only one with 6 sides. Okay, so we've got this one figured out. The next one to figure out is B. So we've got let me see, we've got a base right here. That one there only has 1 base to it, or a bottom, and then it's going to have triangles on each side. So if it's only got 1 square base, you know it's not going to be a prism, it's going to be a pyramid, and that would be this one right here. Now this one has two bases, and they're both triangles, so it's a triangular prism. So let's go down here and find a triangular prism with two triangles for the top and the bottom, and it should have rectangles for each one of the three sides, so right there is your C. Looking at D, we're looking at, again, only one base, and the base is a pentagon. So here's my pentagon with only one base, so it comes to a point. So this is a pyramid, so this is D. This one here has a triangular base, and it only has one of them, so we know it's a pyramid. We're not going to worry about it, but we do know that it will end up being this one here. Two bases, and the bases are in the shape of a pentagon. So we're going to look for a pentagon base and a top right here. So there it is. And this last one right here, we're going to have a hexagon for a base and also for the top, and then 6 rectangular sides. And there it is, a hexagon for the base and the top, and then 6 sides attached. So that's the easiest way to identify and to name what your prism is to look for the base, and then the rest of them will be your sides of your prism. So let's look at this one. Is this a prism, a pyramid, or a cylinder? Of course, we've got one base, so it's going to be a pyramid. This one here is going to be another pyramid because it only has one base, and then it has the sides. All of these will be prisms because, well, this one has a triangular base, so it's a triangular prism. This one has a rectangular base, so it's a rectangular prism. There's our typical cube. In other words, it has a square base. You don't hear the word square prism. This one here is a pentagonal prism because it has a pentagon or a 5-sided figure for the base, and then rectangles for all the sides. This one's a hexagonal prism because it has a hexagon for the base and the top, and then all rectangles on the sides. And again, 2 more pyramids.